Hello and welcome. Let us talk about the RCP scenarios in terms of representative concentration pathways. So, this is the 12th lecture, third week and the second lecture of third week. So, as far as the IPCC provision is concerned in terms of various scenarios, in last class we talked about SRES and today we are going to discuss about the representative concentration pathways, that is abbreviated as RCP. So, what we will highlight? The highlights are the concepts covered are overview of RCPs. So, we will discuss what are the overview of this RCP, that means the representative concentration pathway, and the various development processes, why there is there have been the need of these RCP scenarios, while we have already a SRES scenarios or IS 92 before that. And then we will go and discuss about the long term climate system response and few model projections in terms of sea level rise and warming, and then another situation or scenario we call the key emission levels and uncertainties and the confidence levels, also we will talk about that. And in terms of another scenario which we are talking with respect to 2030 is the ECPs, the extended concentration pathways. So, we will also discuss about this. Friends, these RCPs, they are these scenarios are calculated mostly with respect to or up to 2100, that means end of this 21st century. And let us move on to understand what is the basis or you say the uses of physical greenhouse gas concentration and the storylines. So, friends, as in the SRES scenario, that means the previous class what we have discussed in terms of emission scenario. So, that is abbreviated SRES. The RCPs is the next one up to that. So, these old scenarios, that means IS 92 and SRES scenarios, they lacked, that means there is deficiency of sufficient details for modern climate models. So, that means the modern climate models accommodate lot of details which were missing in the previous scenarios such as IS 92 and SRES. So, that means there is a need for high resolution emissions and the land use data incorporation into that, and the policy relevant mitigation pathways, the pathways which are more relevant as far as the policies is concerned, and the climate projections beyond 2100 for long term what you say trend analysis or situation information. So, this became the need for generating or developing these RCP scenarios over the IS 92 or SRES. So, as far as the RCP stands, representative, it stands for many scenarios, it is the representation, and concentration term is now used instead of emission scenario. So, it is the moment we talk about concentration, we are here focusing more over the greenhouse gases concentration or the greenhouse gas level in the atmosphere, and we are saying the P stands for the pathways. It is a pathway, it is not a scenario, it is the pathway. Okay. So, that means it shows the changes over time. So, as far as the RCP, the main four what you say lining are named as 2.6, 4.5, 6.0 and 8.5. So, 2 points you all must have came across these numbers 2.6, 4.5, 6.0 and 8.5. As we move on, we will understand what are they represent. So, what are RCP 2.6 represent? It is designated to limit the warming to less than 2 degrees centigrade by end of this century. So, strong policy implications and strong what you say greenhouse gas or carbon dioxide control level, that means we have a net impact as far as the warming is limited to less than 2 degrees centigrade in comparison to the 1850 to 1900 average. So, that is the comparison we already know or discussed. So, as far as RCP 4.5 is concerned, the moderate climate policies and emission peak during mid century, then it declines. So, this represents the RCP 4.5 and it converges or it indicate it fits to a scenario where the climate policies are at moderate level. Then coming to RCP 6.0 is the limited mitigation. So, the mitigation impact here is limited. So, growth is slower. That means, in this kind of RCP 6.0 scenario, the warming will go up to 3 to 4 degrees centigrade in comparison to our benchmark, the base what we take as 1850 to 1900 average. So, that means, this also links to delayed action as far as the mitigation activities are concerned. So, now let us move on to the next one or the extreme one, which is represented as RCP 8.5. So, rapid economic growth and population growth and business as usual scenario, we do not incorporate any kind of mitigation impact or any kind of strong policy intervention. So, in this scenario, the RCP is represented at 8.5 in terms of its what you say level, and this scenario may lead to or may link to a kind of warming which will be more than 4 degrees centigrade by end of this century, that is 2100. So, as we move on from 2.6 to 4.5 to 6.0 to 8.5, the scenario becomes more pessimistic and the warming may go up from less than 2 degree to 3.4, 3 to 3 and more than 4 degree centigrade by end of this century. So, this is what actually is the representative in terms of the concentration and the overview. As far as the overview of this RCP is concerned, now we all know this classification. This classification is based on the target radiative forcing. So, 2.6, 4.5, 6.0, 8.5 as the radiative forcing level. Friends, all of us know the radiative forcing term. It is the net energy imbalance in Earth's climate system that is caused by the greenhouse gases and other climate drivers. So, now as far as the RCP classification is concerned, it is based on the target radiative forcing as I just mentioned, and the level represents in terms of the watts per meter square, and it is relative to the pre-industrial conditions. And as these markers which are standardized by IPCC, forcing levels 2.6, 4.5, 6.0 and 8.5, this span over a range. On the left hand side, please look at these 4 figures, diagrams which have been picked from the synthesis report published by IPCC in 2015, and on the x axis you can see the year. It is going from 1950 to end of this century. On the y axis it is the gigaton of carbon dioxide per year. For the middle it is the gigatons in terms of the methane per year, and with respect to this we are seeing for carbon dioxide, methane, nitrous oxide and sulfur dioxide. So, and on the right hand side, upper right hand side, the scenarios have been indicated in terms of the marker scenarios are indicated in terms of red, little dark red, cyan and blue color in terms of 8.5, 6.0, 4.5 and 2.6, and we can see the range in terms of the tons of that particular greenhouse gas emission per year. So, 8.5 is the most or the highest pessimistic kind of scenario which you can see forms the upper boundary, whereas always the RCP 2.5 represents the lowest or the very optimistic scenario in terms of the emissions as far as the emissions of different greenhouse gases are concerned. Now, coming to the lower right portion which talks about the carbon dioxide equivalent concentration in ppm, and you can see the working group 2 scenario, which is more or less 5 to 90% in terms of the confidence level. And you can see the because of this how the trend as far as the relative forcing with respect to the 2100 relative to 1750 is depicted in terms of the watts per meter square. So, now let us see how they have been developed. So, what led to the development of this RCP package or RCP scenarios, okay, or the pathways, I am sorry, the pathways. So, representative concentration pathways. So, you can see you have some 7 plus 7 different numbers. So, first one is the IAMs, that stands for integrated assessment models. So, what do you mean by integrated assessment models? So, for these RCPs, the integrated assessment modelers, the climate modelers, the terrestrial modelers, and the socio-economic people also, they all have the greenhouse gas the gas emission scenario or the atmospheric emission group. These 4 groups, they came together and they tried to put it in terms of the integrated assessment. So, socio-economic scenario into harmonized graded concentration based climate pathways called the RCPs. So, first select the pathway, update, harmonize in terms of emissions and the land use kind of change, grid land and the emission 0.5 to 0.5 in terms of the representation, spatial representation, convert to concentration in terms of climate chemistry based models, then extend and publish. So, let us see the number 1 and 2 in terms of socio-economic, land use, land cover, emission data, concentration and climate data, graded emissions. So, this have come from this, and now the historical land use, land cover came from the land cover model group, GLM, global land model, and then you have the historic concentration data that is coming from MAGICC 6, a kind of well mixed greenhouse gases. Friends, when you talk about WMG, this well mixed greenhouse gases, we know that this takes care of the dominant greenhouse gases, that is the carbon dioxide, methane and nitrous oxide. So, this greenhouse gas concentration and the RCP extension, they form the next layer in terms of the well mixed greenhouse gases. Now, the reactive gases and the aerosols which came from the CAM 3.5 in terms of atmospheric chemistry transport as far as the concentration fields are concerned. So, these all then move on to the RCP repository, which is the RCP database. So, it includes all these 5 as we just discussed, provision of data for historical period, RCP period and the extension period. So, RCP period here we are taking 2005 to 2100, the extension period we are taking with respect to 2100 to 2300. So, that is the extension period. So, 21st century to 2100 to 2300, another 200 years beyond. So, land use and land cover data, the harmonized greenhouse gas emission, greenhouse gas concentration, graded reactive gas emission and ozone and the aerosol concentration facts. So, this is how the RCP development has happened, and the process looks like this as far as the Van Buren et al. Publication is concerned. This has been picked from there. And then moving on in terms of the overview, we just mentioned 8.5 rising radiative forcing pathways leading to 8.5 watts per meter square. So, this radiative forcing pathway or this radiative forcing up to 8.5 watts per meter square could be equivalent to 1370 ppm of CO2 equivalent by end of 2100. Currently, we have about 425 plus. So, RCP 6, that means it is a stabilization without overshoot pathways to 6 watts per meter square. So, if this kind of pathway could be or equivalent to 850 ppm of CO2 equivalent at stabilization after 2100. So, here the stabilization will be after 2100. In case of the previous scenario 8.5 pathway, it is by 2100, that means by end of the century. So, moving on to RCP 4.5, stabilization without overshoot pathway to 4.5 watts per meter square. So, that is equivalent to a 650 ppm of carbon dioxide, and here the stabilization also will happen after 2100, that means beyond this century. And look at the more optimistic scenario, that is RCP 2.6, the pathway peak in radiative forcing at around 3 watts per meter square. So, this is again equivalent to 490 ppm of carbon dioxide equivalent, that may happen before 2100. So, this is this looks like the one which is going on, because now we are at 425, let us see. And then so, by this it will happen in terms of achievement, and then decline the selected pathway. The selected pathway declines to 2.6 watts per meter square by 2100. So, it says that it will go up to 3 watts per meter square, and it will again decline to 2.6 by end of by the time we achieve the end of this particular century. So, it will achieve its peak and again will come down. So, this is how this is what is the overview of the RCPs, but if we discuss about the main characteristics of each RCP, the scenario component, greenhouse gas emission, agricultural area and air pollution. RCP 2.6, 4.5, 6 and 6 we usually say 6.0, and RCP 8.5. So, as far as greenhouse gas emission is concerned, for RCP 2.6 it is very low, then for 4.5 it is very low baseline and medium to low mitigation. Then for 6.0 it is medium baseline, high mitigation, and for 8.5 it is very high baseline. For agricultural area, medium for cropland and pasture, very low for cropland and pasture for 4.5, medium for cropland but very low for the pasture. It is total is very low as far as the RCP 6.0 is concerned. And coming to air pollution, for 2.6 it is medium to low, for 4.5 it is medium, but as we move on to 8.5 it is medium to high level. Now, with respect to the available information from RCPs and the resolution, we can see for different in terms of emission of gases, carbon dioxide, methane, nitrous oxide, the HFCs, PFCs, CFCs and SF4, and on this side you will see that the resolution sector, land 12 sectors, summation of these 12 sectors, but as far as the geographical resolution is concerned, some are global and for 5 regions, and methane it is 12 sectors, 0.5 to 0.5 degree grid, whereas for nitrous oxide, hydrofluorocarbons, PFCs, CFCs and chlorofluorocarbons and SF4s, this is global and for 5 regions as far as the available information is concerned. Then coming to sulfur dioxide, black carbon, it is 0.5 by 0.5 degree grid, very good in terms of the resolution among all. And then the concentration of greenhouse gases, it is again a global distribution and the resolution is geographical resolution is global. So, from this table it is very clear that the information available from the RCPs and the resolution, they vary for different greenhouse gases, different aerosols and different VOCs, and also in terms of the land use land cover data. For land use land cover, you see 0.5 by 0.5 grid with sub grid fractions in terms of annual maps and transition matrices, including the wood harvesting. So, the database and resolution which is available as far as the RCPs are concerned is this. Now, friends, let us look at the RCP drivers. So, you have 3 sets of information or depictions. So, you see in case of the upper left, the population and the GDP has been projected with respect to these 4 different pathways. In the lower left, the primary oil energy trends across RCPs have been given or have been projected, whereas for the upper right or you can say middle, it is the energy mix and the carbon intensity in terms of RCPs. So, the range what has been projected there, it is all between 98 to 98th and 90th percentile as far as the light and the dark gray is concerned. Oil use declines only in RCP 2.6. If you focus on RCP 2.6 scenario, you will see the oil use declines only in the RCP 2.6, not in other kind of pathways. So, renewable bioenergy and nuclear energy increase in all RCPs in terms of their utility. For fossil fuel with radiative forcing level, fossil fuel increase, and all RCPs still use coal and gas in 2100, but with the CCS, with the carbon capture and storage options. So, let us look at the lower right or you say the middle one, which is a cumulative area, a cumulative kind of representation in terms of triangle. On the left side, it is represented in terms of renewable and the nuclear energy utilization. On the right side, it is the fossil fuel without the carbon capture and storage or CCS, and on the base it is fossil fuel with the carbon capture and storage. Now, with this label, the bar goes from 0 to 1, and you can very well see how the dots they move, and based on you can see that where the RCP number what lies as far as this kind of fossil fuel or the energy scenario is or energy consumption pattern is concerned by the year that is 2100. It is very interesting to understand this kind of representation, but they give a lot of facts in cumulation. And let us move on to the global warming versus the cumulative carbon dioxide emission. So, the graph itself shows on the left hand side is the temperature change relative to 1861 to 1880 in terms of degree centigrade. On the x axis, it is represented the cumulative total anthropogenic carbon dioxide emission from 1870. So, there if we see it, the whole of this representation as far as the total human induced warming, carbon dioxide induced warming is concerned, it is increasing. It is increasing by end of what you say 2500 in terms of the cumulative total anthropogenic carbon dioxide emission is concerned. So, the model spread, what it implies, the model spread widens under RCP 8.5, and these eclipses in terms of you see link emission totals to warming levels. So, the warming levels in terms of the emission totals is linked. The warming level is represented on the y axis in that is the temperature change relative to 1861 to 1880 in terms of degree centigrade. So, that is related here. Coming to the black eclipses, this is here observed emission and warming. So, till means till date it is in terms of the observed data, and warming rises linearly with respect to cumulative carbon dioxide. RCP's future emission or warming paths. Then you can see the black lines are the historical trends, these black lines, and the dots are the decadal, these dots are the decadal average. So, this actually gives an indication of the global warming vis-a-vis the cumulative carbon dioxide emission. Now, friends, let us move on to the characteristics of the scenarios, key emission levels, uncertainties and the confidence. So, this table again have been picked from the synthesis report. You can see here that the table indicates the carbon dioxide equivalent concentration in 2100, which is represented in terms of ppm. So, on the left hand side, the column on the left hand side talks about the CO2 equivalent concentration, and then you have the subcategories in terms of the no overshoot, overshoot and total range. Then the third column is important, that talks about our RCP scenario, RCP pathways, RCP 2.6, 4.5, 6.0 and 8.5. Now, the next one is the change in the carbon dioxide equivalent emissions compared to 2010 in terms of 2050 and end of that century. So, this is already shown in terms of the change in the carbon dioxide emission scenarios by mid of this century and end of this century. So, what are the uncertainties and the confidence level? The baseline 2.5 to 7.8 warming by end of this century, 2010 emissions, that is 31% versus 1990, 2011 level 430 ppm, so average of 340 to 520, 2050 emission scenario you can see minus 72 to 95% versus 2010, and 2100 emissions is minus 107 to 120% versus 2010 in comparison to 2010. So, CMIP 5 gaps shows that there is high uncertainty. Why this uncertainty exists? So, the uncertainty exists because of limited observations. So, the number of observations perhaps are limited to represent the heterogeneity of the what you say, the emission pathways, and then at the emission level. Then the complex system interaction, perhaps we need to understand more as far as the system interaction, the complexity of system interaction is yet to be fully understood. Then changing the future drivers, the drivers which are actually changing or interacting in terms of future is still means the change is still not properly what you say, taken care. So, that there could be some uncertainty because of that, and the possibility of lot of surprises. Lot of surprises means many things might happen in future. Suppose a war like what is going on between Russia and Ukraine. So, these kind of scenario are a kind of uncertainty or surprises. So, any of these actually contributes to this kind of uncertainty, and also the confidence level matters in terms of the confidence level. So, the projected warming and sea level rise, we can see it in terms of the global mean surface temperature change in terms of degree centigrade, and the global mean sea level rise in terms of meter. So, scenarios have been given in the second column, the mean, the likely range 0.4 to 1.6, the mean is 1 as far as the temperature is concerned with RCP scenario 2.6, whereas the global mean rise may be likely between 0.17 to 0.32 with the mean of 0.24. So, this is for the year 2046 to 2065. So, if you go for 2081 to 2100, it will be little higher. So, for the RCP 2.6, for the global mean surface temperature could be 1 with a range of 0.3 to 1.7 degree centigrade, whereas the global mean sea level rise could be, the mean could be 0.4 with the range between 0.26 to 0.55. So, all others are already projected or shown in the slide. So, by mid century warming diverges strongly depending on the emission scenarios. Late century warming spans from 0.3 degree centigrade, that means RCP 2.6 to 4.8 degree centigrade, that is RCP 8.5. Look at the projection as far as the temperature is concerned. To 0.3 degree centigrade is a very optimistic scenario as far as the pathway RCP of 2.6 is concerned. It may go up to 4.8 degree as far as the RCP 8.5, it is a very pessimistic scenario. More hot extremes, fewer colder extremes, heat waves becomes more frequent and long lasting. This has been picked from the synthesis report given in 2015. Now, let us move on to this extended concentration pathway, that is with respect to 300. So, with respect to this 8.5 all these things, it will be still a different kind of scenario, follow stylized emission trajectory that leads to a stabilization at 12 watts per meter square. ECP 6.0 stabilized concentration in 2150, that is 6.0 watts per meter square. So, this has in terms of land use, all ECPs keep constant at 2100, because there may not be a lot of changes to happen as far as the land use is concerned. So, as far as this extended concentration pathway is concerned, the radiation level or this could stabilize with respect to 8.5, 6.0, 4.5 at 12, 6 and 4.5 watts per meter square, and the representations are very clear as far as the extension ECP is concerned, radiative forcing and the greenhouse gas trend is concerned till 2300. So, for this particular lecture number 12, we have used these two, particularly the climate change 2015 is the synthesis, longer report is 15. So, 14, 15 both have been put in this way, and one published material that also have been put here. So, in summary or in conclusion, what we discussed about the RCPs. So, RCPs are concentration based pathways designed for long term policy relevant climate projections. They are classified by standardized radiative forcing targets from 2.6 to 8.5 watts per meter square. Higher cumulative carbon dioxide causes stronger warming, ice loss, sea level rise and ocean acidification. Climate model uncertainty and impacts increase significantly under high emission, that is the RCP 8.5 pathway. Long term stabilization requires rapid decarbonization and negative emission through carbon removal technologies such as the CCS, or you say carbon capture utilization technology. So, in our future classes we will discuss more, but in the immediate next class, that is lecture number 13, we are going to discuss on the SSPs, that is shared socioeconomic pathways. Thank you very much. Look forward to see you again soon.